So as we move into factoring general trinomials, question 3 says factor this completely. V squared minus 9v plus 20v. So notice how, again, this is not a difference of squares, and it's not a perfect square trinomial because there's nothing squared that's going to give me a 20. So this makes this a general trinomial because it doesn't meet one of the special products. This does not make a perfect square. So we have to do what we call a general trinomial. So again, we can treat almost everything like a general trinomial. This kind of becomes a one size catches all. Now remember, what we used to do is multiplying things together. So if I gave you, say, x minus 5 times x minus 2, we could use FOIL and find the product. So if I bring the x through and then bring the negative 5 through using FOIL, we're going to get then this x squared minus 2x minus 5x plus 10. So this ends up being x squared minus 7x plus 10. So notice that this is the factored form and this is the product. Notice this time they give us the product and they want us to find the factored form. Now remember, instead of using FOIL, we can use the box, or what we call Foursquare. So I can put the x minus 5 here and the x and a negative 2 here, if you will. And I kind of Foursquare it off here. And then what I can do is multiply, and I usually start at the top and work my way this way. X times x is x squared, and negative 2 times x is negative 2x. And then x times negative 5 is negative 5x, and negative 2 times negative 2 is a positive 10. So if we put this all together, we have x squared, and notice how these are like terms here. Those middle terms actually appear in a diagonal. That's going to be a minus 7x, and then there's our positive 10. There's our three terms in the end. So notice how it gives us the same answer as FOIL. Some things to pick up on, though, is notice that the quadratic term is in the first box. Notice how the quadratic term is here, and the constant is here. And then notice that these are my two middle terms. But if you notice the coefficients, so the negative 2 and the negative 5, notice that those were the factors of the constant. Negative 2 times negative 5 does give me the 10. The negative 2 plus the negative 5 gives me the linear coefficient. So when I factor this, what we kind of pick up on is we can kind of do FOIL backwards. So since the coefficient of v squared is a 1, this makes this pretty easy. If the coefficient of the quadratic term, again, the quadratic term is the degree 2 term. The degree 2 term, if its coefficient is 1, then all we have to do is focus on the factors of the last term, which is the c. And the factors of the last term must equal the linear term coefficient. So again, linear term means degree 1. And notice how x has a power of 1 here. We just don't show it. So linear term is degree 1. So this is called the linear term because x has a power of 1. So we're focusing on its linear coefficient, or simply the b. So really all we have to do is focus on these two items, the factors of the c that add up to b. So in our example, if we look at the factors of a 20, they must add up to a negative 9. So again, if I use my table on my calculator, I can go y equals, I can go 20 divided by x. That looks good. Yeah. So if I make my table, so if I go here, it can generate a table for me. So we have 1 and 20, because 1 times 20 is 20. 2 times 10 is 20. 3 is not a factor of 20 because notice how this gave me a decimal answer. We're looking for whole number stuff here. 4 times 5 is 20, and 5 times 4 is 20. But notice how that's just the same thing as 4 times 5. So I just draw a line through that and say, we just got to focus on these three pairs. Now the catch is, though, 4 plus 5 looks good, but it does not give me a negative 9. So we have to do some work here. To get a -9, they would both have to be negative. So if I make them both negative, though, the other catch is, does -4 times -5 still give you a positive 20? Well, yeah, a negative times a negative does give me a positive 20. So sometimes our factors are actually going to be negative. So -4 times -5 is a positive 20. -4 plus -5 does give me a -9. So this tells me that this is my winner. So when I factor it, what's easy about this is the quadratic term, the v squared, just takes up the first two positions. So all I got to do is set up two sets of parentheses. The v is going to be here. The v is going to be here. What goes in these last two positions are the factors of the last term. So the -4 or the -4 and the -5 become my completion of the factorization. So this becomes the factored form. So v minus 4 becomes a factor. V minus 5 becomes a factor since they're connected to location. So those two factors give me, if I multiply it back out, they would give me this v squared minus 9v plus 20. So this is what we mean by factoring.